Ever had a conversation with an AI where it seemed super smart, but then said something totally made up? Like, oh, the capital of Peru is Paris. Laughs, that's a hallucination, when AI generates false or misleading information. And it's a big deal. Today, we're diving into how researchers are tackling this problem, with a focus on a groundbreaking project called ATLANTIS. So what's the issue? Large language models, LLMs like GPT or Gemini, are amazing at creating text, but they're not perfect. They can hallucinate facts, which is a problem when they're used in critical areas like healthcare or journalism. Imagine a medical AI recommending the wrong treatment because it made up the data. The ATLANTIS team worked on SemEval-2025 Task 3, a challenge to detect these hallucinated text spans in question-answering systems. Their goal? To make AI more reliable. And they crushed it, ranking first in Spanish, top 5 in German, and strong results in English. How'd they do it? Let's break it down. They tested two main approaches, without external context and with external context. First, the no-context method. They used a simple rule. If a word in the answer doesn't appear in the original text, it's probably a hallucination. Think of it like fact-checking by eye. But this only worked well in English, since their data was limited. Then they tried prompt engineering, custom instructions for LLMs. By giving the model examples and a structured format, like JSON, they taught it to spot fake info. For instance, they'd say, here's a question, answer, and context. Find the hallucinated parts, adding real Wikipedia snippets as context. Game changer. It's like giving the AI a textbook to reference. But the real magic came from fine-tuning models. They created their own synthetic data, generated answers with intentional errors, then trained models to detect those. One approach used a token-level classifier, labeling each word as hallucinated or real. Another fine-tuned an LLM itself, teaching it to edit its own mistakes. What's the takeaway? Context is key. When AI has access to real-world information, like Wikipedia, it's way better at avoiding lies. And fine-tuning models on synthetic data. It's a powerful way to teach them, without needing tons of human-labeled examples. So why does this matter? As AI becomes more integrated into our lives, we need systems that don't just sound smart, they are smart. The ATLANTIS team's work is a big step toward trustworthy AI. Thanks for watching. If you want to dig deeper into how they built their models or see examples of hallucinations, hit the link below. And don't forget to like, subscribe, and join the conversation in the comments. Until next time, stay curious. Ever wondered why sometimes AI chatbots say things that sound almost right but are totally off? Like claiming the Flash TV show premiered in 2015 instead of 2014. That's what researchers call a hallucination, when an AI makes up facts or messes up details, even if it's trying to help. Let's break this down. Imagine you ask, when did the Flash first air? A good AI should check its data and say, October 7, 2014. But sometimes it might mix up dates or names, like suggesting 2015 or even misspelling Paris as Grants. These errors aren't just typos, they're big red flags for how reliable the AI's information really is. Researchers are testing how well AI models avoid these mistakes. They use special prompts to spot factual inaccuracies, wrong dates, places, or facts, and misspellings, like typos or incorrect names. For example, if an AI says the Jungle Book came out in 1967 instead of 2016, that's a factual error. If it writes Punisher as Puncher, that's a spelling mistake. The key takeaway: even smart AI needs humans to double-check its work. By teaching models to spot their own errors, like highlighting wrong dates or spelling mistakes, we can make them more trustworthy. After all, if we're relying on AI for news, science, or even TV show facts, we need it to get the details right. So next time you chat with an AI, remember, it's not perfect. But with the right tools, we're getting closer to making sure it's mostly accurate. Stay curious and let's keep pushing the boundaries of what AI can do, without the hallucinations.